Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.109. While solving this problem, we will be using delta to star conversion. Here is the list of equations which are used to convert a delta connection into an equivalent star connection. Now move towards the problem. Exercise problem number 2.109. Find the value of current I0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of current through this 2 ohm branch labeled as I0. So without wasting time, let's proceed towards the solution. First of all, we will try to simplify this network. For that purpose, we will start solving this problem from this end. These three resistances are connected in series connection, so we can find their equivalent resistance and replace that resistance with these three resistances. Their equivalent resistance will be equal to the sum of these resistances. 3 ohm plus 4 ohm plus 5 ohm. So R equivalent of this series connection will be 12 ohm. Now we will modify the network by replacing these three resistances with a single resistance having the value of 12 ohm. Now this 12 ohm and this 12 ohm are converted into parallel connection and both have same values. So we will find their equivalent resistance by dividing the value of a single resistance 12 ohm with the number of same resistances connected in parallel connection. In this case, it will be 12 divided by 2. So R equivalent of these two resistances will be 6 ohm. Modify the network by replacing these two resistances with a single resistance having the value of 6 ohm. In order to further simplify the network, we will reconstruct this circuit diagram. Rather than passing this 9 ohm resistance through this closed loop, we will place this 9 ohm resistance outside of this loop, but the connections will remain same. Modify the network diagram. This 9 ohm resistance is placed outside of closed loop. Now it is easy for us to further solve this problem. If we observe, these three resistances are forming a delta connection. So in order to simplify the network, we have to convert this delta into star configuration. For that purpose, we will place a star configuration inside this delta connection and we'll label these resistances of star connection as RA, RB and RC. Similarly, the resistances of delta connection will be labeled as R1, R2 and R3. Now we will use these three equations to calculate equivalent resistances in star connection. We will start from here. RA will be equal to the product of R1 and R2 divided by the sum of all resistances connected in delta connection. Product of 6 ohm and 12 ohm will become 72 ohm divided by the sum of these three resistances will become 36 ohm. So 72 ohm divided by 36 ohm will result 2 ohm. Now resistance RB will be calculated using this equation. Solve this equation to calculate the value of RB, that will become 6 ohm. Similarly, RC will be calculated using this equation and the value of RC will be 3 ohm. Now we have the values of star connection. This star connection is equivalent to this delta connection. So we can replace delta connection with star connection. Modify the circuit diagram by indicating resistances of star connection. At this stage, these two resistances and these two resistances are converted into simple series network. So we will find their equivalent resistances. Equivalent resistance of this series connection will be the sum of 2 ohm and 2 ohm. It will become 4 ohm. And the equivalent resistance of this series connection will be 12 ohm. Now we will modify the network by replacing these resistances with their equivalent resistances. Now the circuit is simplified. These two resistances are converted into parallel connection and both of these are connected in series with 6 ohm resistance. So first of all, we have to find total supplied current through this network. This same current will flow through this 6 ohm resistance Later on, we will try to apply current divider rule to calculate current through this branch. For that purpose, we will find the equivalent resistance of these two parallel connected resistances. Their equivalent resistance will be calculated by taking the product of both resistances dividing by their sum. Product of 4 ohm and 12 ohm will become 48 ohm divided by the sum of 4 ohm and 12 ohm will become 16 ohm. 48 ohm divided by 16 ohm will result 3 ohm, and this 3 ohm will be in series with this 6 ohm. So the total resistance of the network will be 9 ohm. After calculating total resistance of this network, we can calculate total supplied current using Ohm's law. Current will be equal to supplied voltage divided by total resistance. So the value of current will be 4 ampere, and the direction of current will be clockwise direction, leaving from positive terminal and entering from negative terminal. Now this 4 ampere current will come on this node and it will distribute among these two branches. So at this node we will consider this current as total supplied current and will apply current divider rule to calculate current through this branch. For that purpose we will use this equation of current divider rule. I0 will be calculated using this equation. In this case R1 will be 4 ohm and R2 will be 12 ohm while total supplied current is 4 ampere. Place values inside this equation. R2 is 12 ohm divided by R1 is 4 ohm plus R2 12 ohm and total supplied current is 4 ampere. Take the product of 12 and 4, it will become 48 divided by the sum of 4 and 12 will become 16. So 48 divided by 16 will result 3 ampere. So the value of current I0 through this 4 ohm resistance will be 3 ampere. So this was exercise problem number 2.109. Thank you. See you again in next video.